All right, so these are the output files. So for this tutorial, I'll focus on just this one and this one and this and this. So you can open any of them with a spreadsheet software. So let's take a look at the REST finder. So this one has information about the antimicrobial resistance genes. So we can open it with a spreadsheet software and then look at what we have. So each row is a hit, a record. Each row represents an identified AMR genes. So we have the isolate ID here. It will be the same name because we specified just one file. And so all the hits are in that file. And we have the gene name. We also have predicted phenotype, percentage identity, overlap, etc. And we also have contigs. So here, because we have more than one contig, if a gene is identified in a particular contig, then the name of the contig will be indicated here. So this will let you know which contig that gene was found on, that AMR gene was found on. So here we have contig 2. We also have contig 1. So here it tells us that contig 1 and 2 were the ones which had the AMR genes, the antimicrobial resistance genes. So we have the details here. All right, we also have accession number. We have start, end, accession number, sequence, etc. So we can look the gene up using the accession number. Let's take a look at a discussion on the Galaxy tutorial page here. So the Galaxy tutorial page also gives the files and it gives a description. So you can read that or visit the developers GitHub page. I mean the STARAMR developers GitHub page. All right. There's also a discussion here about multi-locus sequence typing. So with the multi-locus sequence typing, the Galaxy tutorial page makes us know that using error-rich sequence data like nanopore, that's long reads, then it's going to be challenging if you try to perform MLST using such kind of data. So you are better off doing it using a short read data, i.e. Illumina. Okay, so that's what this statement means. But I would like you to read it yourself and then try to get the information. And we also have plasmid and then antimicrobial resistance genes. So we have the information here. We also have this one here. It says multiple rep sequences are located on the second contig. So the second contig, ours may be different because we have a slightly different results. So what I have to do is check if you can find the rep sequences. So here, the rep sequences here are found on plasmids. And so what this indicates is that since there are rep sequences, that means that our sequence data likely has plasmid or plasmids. Let's take a look at our file. We will look at the plasmid finder file. So this has information about plasmid. So let's open this also. So if you open it, you will get information. So we have rep sequences. That's what the tutorial is referring to. So we have them here. We have the contigs. So here we can see that rep sequences have been found in all the contigs. So contig 2, 4, and then 1. They all have rep sequences. And then we have the identity here. So identity here is less than 100. So for me, if it's less than 100, I'll want to do some other checks to make sure that these are indeed plasmids. But I mean, once you have these ones here, and then the thresholds you decide the threshold. So for me, I'll go for 100% identity, but it depends on what you want. You can also look at having a threshold less than 100 and then decide if the hit you have is indeed a plasmid or not. Okay, so that's what we have here. And then we also have the session IDs to let you know them. So you can just set the session IDs to check the information about that.